hopefully you understand why linked lists and array lists are sequential based. And that's just because every element lives in sequence to one another. And effectively what that means is that every element lives at an index where the index is of some significance. Okay? There are two other simpler data structures that we'll talk about. One of them is called a stack. The other one is called a queue. Okay? So with the stack, think about a stack of dishes at, let's say you're washing dishes. Let's say you have a plate or a stack of plates beside of you that is this high. Okay? So just imagine these are all plates. I'm not very good at drawing. Okay? So if we're trying to wash the plates, we obviously can't take from the bottom or anywhere from the middle because that will compromise the integrity of the stack. The only way that we can wash the stack of dishes is to take one plate at a time from the top and then wash it. Okay? So we take a plate, then we wash it. We take another plate from the top, and then we wash it. We take another plate from the top, and then we wash it. Okay? That's how a stack works. Stacks are very simple. So you can quite literally just view it as like a stack of stuff. So let's say we have a stack of numbers. Let's say that we have a stack with the numbers 10, 20, 30, 40, 50. And the way to get this, at least in Java, we can do something like stack of integers s equals new stack. Now the relevant operations for a stack are, we have something called push, which adds something to the top of the stack, where the top of the stack is here. We have something called pop, which removes and returns something from the top of the stack. So if we want to mimic this stack right here, we can do s.push, then 10, and then 20, and then 30, and then 40, and then 50. Okay? So if we want to pop the thing off the top of the stack, like let's say we want to get rid of the 50 here, we can do that. We can call .pop, and that will not only pop the 50, but it will also return the 50. Okay? So we don't pass anything to this. That's my bad. There we go. Yeah. So this will remove and return the top of the stack. So this returns 50. Okay? There's also the peek operation. So what does peek do? Peek will return but not remove the top of the stack. So if we push these values and then we pop the top, then we peek to see what's at the top of the stack. What is at the top of the stack now? Well, of course, that would be 40. Okay? So push, pop, and peek, and that's it. That's really all you can do. Okay? So you can process stacks. Really, the main way to process a stack is by doing something like while a stack is not empty. So let's say that S is a stack of stuff. Then the way to process it would be something like, let's just say it's a stack of numbers. Then we can do s.pop, and then we can just process v somehow. Okay, so this will process the items on the stack in this sort of reverse order of insertion. Okay, and that order is actually something significant, and there's a term for it. It's called FIFO, or first. Sorry, that's Q. It's called LIFO. Sorry. It's called last in, first out. And hopefully that kind of makes sense to you. So with a stack, the last thing to go in is the first thing that leaves. So when we push the 50 here, when we pop the 50, or when we pop the stack, the 50 is the first thing to leave. Okay? So there are many algorithms that do rely on stacks, so it's really important to know how they work. Okay? But the actual class in Java is sort of overshadowed by the linked list class, which also has this functionality of pushing from the front, pushing from the rear, and removing from either part. Hopefully you can see how you can implement a stack with a linked list. Okay? You can also implement a stack using an array and then just resize the array and just have a dedicated index marking the top of the stack. Okay? So that's stacks. I think stacks are very simple. There are also queues. Now think of a queue. So let's say you're at the grocery store. Let's say you're at Kroger or at Aldi or something like that, and you get in line to check out. Okay? So this is you, and then let's say there's somebody. So let's say the register is right here. Okay? And let's say that there were 3 people ahead of you. Okay, let's just draw different colors, just for the heck of it. So you're here, and the queue is processing people one at a time. Okay, but the way you enter the queue is via the back of the queue. So let's say that there's somebody else that comes in behind you. Okay, and then maybe someone comes in behind them. Okay, but the way you process elements or process people from this queue is by removing them from the front. Okay, so we process this person, we process this person, we process this person, we process you, we process this person. Okay, we can't process this guy. He can't go ahead because then that would make all of these people very upset, and that's just not how a queue works. Okay, so a queue is exactly like you think it should work in. It corresponds exactly to how a queue works in real life. Okay, so the typical operations of a queue are operations like in queue, and then maybe some implementations will have a dequeue operation. So in queue is sort of like push, except it in queues into the back of a queue. And dequeue is analogous to pop in that it removes the front thing from the queue and returns it. Okay? And then there's also sometimes a peek operation, which will let you see the first thing in the queue, or the thing at the front of the queue. And yeah, so again, queues are very simple. Now you may think, well, why didn't I show you how to do this in Java? Like, how do you create a queue? Well, you may think that you can do something like queue, and then maybe of integers, queue equals new queue. Unfortunately, that's not how Java works. You can't do that. So the reason for that is because there are multiple ways of implementing the behavior of a queue. So queue is actually kind of like how list works. There's something called something that behaves like a queue will be a kind of queue. So for example, like we said, array list and linked list behave like lists. But the thing is, linked lists can also behave like queues. So there's actually 2 arrows coming from the linked list. And again, this relationship of the arrows and whatnot will be much more significant later. But all this means is that if we want to create a linked list, we have to declare it as a queue, but then just instantiate it as a linked list. And this will get you the functionality that comes from the queue type. Okay? So, but the thing is, both of these data structures are, again, overshadowed by the fact that if we just create a list, create a new linked list, if we do this, then we get the behavior of both stacks and queues from a linked list without any downsides. Okay? Now, the method names may not be exactly like enqueue and dequeue or push, pop, and peek, but there'll be things like add first, add last, remove first, remove last, things that are analogous to push, pop, peek, NQ, DQ, and peek. Okay? But one thing I'll say before we end is that stacks, like we said, are LIFO, which is last in, first out. Queues are FIFO. So that stands for, hopefully you can guess this, first in, first out. Okay? So the first person in the queue is the first person to get processed. And it's processed in a linear fashion. Okay? So the first person gets processed and the next person behind them gets processed, so on and so forth. And this applies to, I know we're using the people here as sort of a real world analogy, but that's exactly how they work in Java and any other programming language that implements them.